All right, test 2, number 9, here we go. This one is giving us some information about two lines. So if they're doing that, more than likely, I'm going to need to find the equation of that line. So one of the things that should be kind of in my head at this point is the point-slope form of an equation, which is y minus y1 equals m times x minus x1. And I'm thinking that because, again, they're giving me a point and a slope, so I kind of have two equations here. The first one, again, equation 1 and equation 2. So for equation number 1, I'm going to have a point and a slope. So I'm going to plug in my point, which represents x1, y1, and my slope, which is m. I'm just going to plug that straight into the equation. So this is going to be y minus y1, which is 8, equals m, which is 2, x minus x1, which is 1. So I plugged in my point and my slope. I'm going to go ahead and solve this for y. So it's going to be y minus 8 equals 2x minus 2. Add 8 to both sides, and you're going to get y equals 2x. Negative 2 plus 8 is 6. So equation number 1, there you go. Equation number 2, I'm going to need to find the slope because they're not giving it to me. So I'm going to go ahead and do that real quick before I start. So I'm going to go y2 minus y1. So I'm going to subtract my y values. That gives me the rise. So 1 minus 2 divided by x2 minus x1. That's 2 minus 1. So my slope is negative 1 over 1 or negative 1. So that is my slope, my point. Just pick a point. I don't care which one we pick here. I'll pick 1, 2. So my equation in this case is going to be y minus y1. In this case I'm calling y1 2 equals m, which is negative 1, x minus x1, which is 1. So again, a couple steps here to get this solved for y. So we have y minus 2 equals, distribute that negative 1, that is negative x plus 1, and then add 2 to both sides, and we get y equals negative x plus 3. So I have my two equations. Now this one's asking me, they say the two lines intersect at A, B. Now they say the word intersect, system of equations. First thing that should pop into my head at that point. So in this case, if I have a system of equations, what I'm going to do is I'm going to set these equal to each other because they're both equal to y. Both of these are equal to y. So I don't have a lot of room here, so I'm going to squeeze it into this little space. I'm going to go 2x plus 6 equals negative x plus 3. I'm going to add x to both sides, which gives me 3x. And I'm going to subtract 6 from both sides. 3 minus 6 is negative 3. So x is going to be negative 1. So now that you have x, we want to use that to find y. I'm going to use this equation. It doesn't matter which one you pick. This one's a little easier to work with. So negative, negative 1, because I have a negative x and x is negative 1, that becomes a positive. So 1 plus 3 is going to be 4. So I have my x and my y values right here. So we want to find a plus b, which is these numbers added together. So a plus b is negative 1 plus 4. Negative 1 plus 4 is 3. So now that you have that, they just find the answer that says 3, and that's going to be answer choice B. So number 9 is B, which is 3. So that's number 9. Moving on to number 10. With this one, I'll probably get all my colors out for this. So what we have is I have all my answer choices here. Now they're telling you which of the font has a graph in the xy plane for which y is always greater than or equal to negative 1. So I want it to be greater than negative 1. So if I, what that means, if I have a point right here at negative 1, I'm going to draw a line right here. And I need to make sure my graph is always greater than that line. That's what they're telling me. So we have to understand transformations for this. So I'm going to go through each one of these graphs. You have to know parent graphs and transformations. I'm saying that for concepts for you to study if you don't know the concepts that I'm about to show you here. So the first off, this parent graph for A is an absolute value, and it's going, in this case, down 2. So I have a graph that goes down 2, and it's going to be a V-shaped graph. So notice this one is not going to be correct because it goes below -1. We want to always be greater than that value, or equal to, which is fine as well. So this one, same thing. For b, I'm going down 2, but this one's a parabola. So I start at -2. You have to know your parent graph, and you know to move that down 2. And again, it's just going to be a parabola, and it's obviously, again, it's touching down here, so that's not going to work either. So that one's ruled out. Answer choice C, this one here is going right to. If you know it's going right to, then you'll just go right to. This is a parabola because it's an x squared, so it's going to be here. It's going to be a U-shaped graph. And notice it's always greater than, that's kind of ugly, you kind of make it fit there. But that's above that line. So that's going to be your answer. So your answer is C. Just to show you what D would look like, this one as well is going down 2. So it's an x cubed graph. So it's going to get flat at -2 and go up. And again, the only one that's always above that line is going to be C. So again, obviously D wouldn't work either. So number 10 is going to be C. Moving on, we have number 11, and it's telling us which of the following complex numbers is equivalent to that. So when you see a complex number, more than likely what we're going to need to do is simplify it. And simplifying is rationalizing. And the reason for that is just you want to remember that I is a square root. It's the square root of -1. Because of that, we have to use rationalization techniques to help simplify. What that means in this case, if you have a binomial, the way to rationalize a fraction, a denominator, when you have a binomial in the denominator, is to multiply by what's called the conjugate, which in this case is 8 minus 2i. Again, this is nothing more than a simplification problem. So I'm going to multiply by the conjugate. So not only are we using this idea, which will help us, but we also need to know this. A plus b times a minus b is going to equal a squared minus b squared. This helps us simplify my, my denominator when I'm rationalizing this. So on top, we are just going to FOIL, so there's nothing too crazy going on here. So this is going to be 24. Outside terms is minus 6i. My inside terms is minus 40i. And my last terms is going to be plus 10i squared. That's my numerator. My denominator, this is where we get to use this difference of squares. I have 8 times 8, that's 64. I have minus 4i squared, that's b squared. A squared minus b squared. What's going to happen is I shouldn't have a radical on the bottom when I do this right. So next to note over here, 10i squared is going to equal 10. Because I is the square root of -1, I squared is equal to -1. So this becomes 10 times -1, which is -10. Same thing over here. Take this minus 4 times I squared, and we have minus 4 times -1. So I'm just taking this. So that's going to equal, in this case, positive 4. So I have 24 minus 10, so that's going to give me 14. I have -6 minus 40 is -46i. That's my numerator. My denominator is 64 plus 4, because these negatives cancel, so that's going to equal 68. Now, if you look at your answers, you don't have that answer choice necessarily, but you see if you look at C and D, they have a 34 on bottom as a common denominator. So I'm going to think, oh wait, I can pull out a 2 from my numerator. So that's going to be 7 minus 23i. That's over 68. Notice the 2 cancels, so we're going to get 34 on bottom. So I have 7 minus 23i over 34. And that's going to equal, in this case, C. All they did is they separated that fraction. So number 11 is C. So now moving on to number 12. Number 12 is asking you to solve, if you just look at the answer choices, forget this big long paragraph. Just notice everything here is solved for f. we're solving this for f. That's all you're really doing. So this is what's called a literal equation. So we are solving this equation for another variable, in this case f. So the way we're going to set this one up is we're going to make it first a proportion. Just put a 1 underneath the r. It really helps get rid of this fraction. So we're going to cross product here. So I'm going to have r times n plus f equals 1 times f, which is f. So again, remember, if you look at the answer choices, we're solving for f. I'm going to go ahead here. I'm going to multiply by r. So rn plus rf equals f. And that allows me to get the f's on the same side of the equation. So that means I'm going to subtract rf from both sides. So I have to get the f's on the same side to get f by itself. So rn is equal to f minus rf. So what I'm now going to do is, the only way to get these two f's to become one f is I need to factor out a GCF, which in this case is f, and that's going to leave me with 1 minus r left over. So now I've taken both those f's and combined them into one f. So now I can divide both sides by 1 minus r, and that's going to give me f equals r times n over 1 minus r. So we're going to look and see which answer choice does that. And if you notice, answer choice B is going to give me that answer. So that's going to be number 12. And then we're going to move on to number 13. So I just need to figure out what color I'm going to use. I'll use orange. So number 13 is wanting us to find the sum of all the values of m in this equation. Now, the thing is the sum. That means technically, they want all the solutions. Now, one thing you may have noticed when you tried solving this problem is that it doesn't factor. So, it may sound scary, but we have to use, in this case, the quadratic formula. So that's going to be, in this case, I'll set it equal to m. But it's m equals the opposite b plus or minus the square root of b squared minus 4ac all over 2a. So this sounds a little daunting, but remember what they're asking for. They're asking for the sum of your solutions. So I'm going to try to give you a little bit of a shortcut on this. So this is just equal to opposite b. What I'm going to do is I'm going to take this 2a and separate it. So that's just a common denominator. So that's equal to the square root of b squared minus 4ac over 2a. Now, there's going to be two answers to this problem. There's going to be opposite b over 2a plus this, and opposite b over 2a minus this. Well, if you notice, if you add those two up, these are just going to cancel out. So we just have this, and then, obviously we have a second one as well, because we have this plus that, and this, again, minus that. So I'm just going to take opposite b over 2a, and I'm going to double it. So what we need to do is figure out what is a, what is b, what is c. So you can factor out a 2 here to start, but it doesn't matter. I'm just going to call this a. I'm going to call this b, and obviously this is c, although I don't need it for what I'm doing. So that means my solution is going to look like this. I'm going to go m equals opposite b, which in this case is 16, over 2 times a, which is 2. So get that back in there. So this ends up being 16 over 4, which is 4. Now remember what we're doing. This is 4 plus some stuff, and then it would end up being 4 minus some stuff. So your answers are 4 plus blah, 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 and, because we're adding these answers together, right? And 4, opposite b over 2a, minus blah, blah, blah. And again, those blahs cancel. We get 4 plus 4, which in this case is equal to 8. So our answer is actually going to be 8. Now if you notice the way this worked, because these discriminant and over 2a cancels, you're not going to have any radicals here if these cancel. So anyway, when I get 8, I know my answers can't be b or c. It had to either be positive 8 or negative 8. If you were kind of stuck and if you kind of remember doing this type of problem, but you forgot exactly how to do it, you at least know it's not going to have a radical in it. In this case, it's a positive, so my answer here is going to be D. So that's going to be number 13. So that's, again, 13. Moving on, I'm going to do number 14. And 14 uses words like decays and percentages, initial amounts. And if I look at my answer choices, this is going to be an exponential equation problem. So on this one, we have the equation y equals a times b to the x. A is your initial value, and b is your rate. Usually that represents a percentage of growth or decay. So in this one, we have something decaying at a rate of 13%. So my rate is going to be 1 minus 0.13. You have to understand your rate is not 0.13 because, again, you are going down 13%, which means you are left with 87% each, in this case, annual rate. So each year, you're left with 87% of what you had the year before. So your rate is always going to be 1 plus the rate if it's going up, or 1 minus the rate if you're going down. So in this case, that's going to be your rate. Your initial value is the initial amount, which is 325. So that is all you really need. I know my equation is 325 times 0.87 to the x or t, or whatever the equation is. So if you look, that is going to be answer choice A. You just match it up, and that is your answer for number 14. So that one's actually pretty quick. So keep it moving. Number 15. It says this expression is equivalent to which of the following. So they want you to find an equivalent expression to this. This is nothing more than you can do this as a quick division problem. So this is a time where I like to use a method called synthetic division. And again, I bring these topics up if it's something that you don't know or don't remember. I'm just going to use synthetic division. So it's a concept that you can look up and see more information on if you don't know what I'm doing. So if I'm going to do synthetic division, I take the root of the denominator, which is -3, and I'm dividing that out of the 5x minus 2. So I'm going to write the coefficients on top. So 5 and -2, those are my coefficients for x and my constant. And before you start synthetic division, you pull down the first term. This is the setup for synthetic division, something to study if you don't know what this is. You want to know what this is, it's really cool. So I'm just going to multiply and add, so this is going to be -15, and -2 plus -15 is -17. So now that I've done this division, they're just saying, and you have to know what it means, by the way. So this is I write that first, this is my remainder, and this is my quotient. So I have, in this case, 5 minus 17 over x plus 3. Because again, this is what I get out of the division, but this hasn't been divided out. I wasn't able to get it out of there. It's left over. So it's still being divided by x plus 3 because I wasn't able to divide it out. So that is what this means. And we just want to find the answer that says that. So if you look at D, is it D? Yeah, look, 5 minus 17 over x plus 3, that is D, and that's your answer. Now, in this problem, you could always work backwards as well and look at the answer choices and get common denominators and add them up, but this is so much faster. So that's why I want to show you that, and I want you to make sure you know, because there are other problems you need synthetic division on as well, so it's an important tool to have at your disposal. And that brings us to number 16, the last one for this video. So 16 is saying we have a sales manager of a company is awarded a total of $3,000 in bonuses to the most productive salespeople. So these bonuses were awarded in amounts of $250 or $750. So we have two rates here. We have a certain amount of people are getting a $250 bonus, and a certain amount of people are getting a $750 bonus. So this is going to be one of the popular types of equations on the SAT, and I like to call it a cost equation because it's usually related to cost. It doesn't have to be, but it's a very popular one where it's just AX plus BY equals C. It's your standard form equation. And this one we have two rates, and it adds up to 3,000. So we have 250x plus 750y equals 3,000. So that's your equation. Now normally you need a second equation to solve this, but notice the way they're asking this question. What is one possible number of $250 bonuses awarded? All I know is that these represent people. You can't have half a person, so I just want to find some whole number solutions that add up to 3,000. So they are telling you have to have at least one per person at least. So I can't like make one 0 and divide that way. But I could make, and I want to solve for x, I could make this 1 and go from there. And that's all you have to do here. Just pick a number for y. That way you have one variable to solve for, and solve for it. So I'm going to call y1. So I'm going to say 250 times x plus 750 times 1, which is 750, equals 3,000. And I'm just going to solve that for x. So I'm going to see what I get, and that'll be my answer. And again, it's only one possible answer. There are other answers you can have if you want to call y2 or 3 or whatnot. Just make sure that x can't be negative, it can't be a decimal. So if you get any of those answers, you're going to have to pick something else. But here it's going to work, and almost any number you pick will work as long as you don't go too crazy. But anyway, we're going to 250x equals, and that's going to be 2250. And it's going to go ahead and divide by 250. Now remember, this is a no calculator section, so you got to use some common sense here. I know that 250 goes into 1,000 4 times, so it's going to go to 2,000 8 times. So 8 goes in, 250 goes into 2,000 8 times, and we have another 250 right here, so this is going to equal 9. And again, just pick an answer, that's a whole number, so it works. So 9 would be the answer I would pick here. And again, based on the numbers you pick, you could have gotten 3, 6, or 9 for this one. If you picked 1, 2, or 3 for y. If you pick 4 for y, it gets to be above 3,000, so you'd have a negative x, so it wouldn't have worked. So anyway, that's what I got, and those are some other answers you could have gotten for number 16, and that is it for this video for Test 2, Section 3.